Swayam Prabha. Digital India. Educated India.
Hello, welcome to this fourth lecture of Module 10 on engineering geological facets of natural hazards and mitigations, landslide, earthquakes and induced seismicity. In previous lectures, we have discussed about landslide causes, factor affecting landslide, hazards, etc. Now in these lectures, we will discuss about earthquake. In this lecture, based on earthquake, we are going to discuss about earthquake, then seismic waves and some basic terminology related to earthquake, then different scales, causes of earthquake in view of classification, then seismic zonation of India. Friends, as you know, the earthquake is the rapid vibration of ground caused by sudden fracture of movement of large segment of rock strata in earth crust, become site for generation of seismic wave in form of burst of energy. You can see the impact of earthquake. The earthquake is a very disastrous natural phenomena causing damage to life and property of society or peoples. You can see the impact of earthquake recently occurs in Turkey and Syria of magnitude 7.5 on 6 February 2023. Before this, the peoples have received lot of pre-shocks. This event has damaged huge numbers of life, property, buildings, destructed road, dams, etc. The vibration may cause extensive damage to man-made structures such as building, road, bridge, dams, triggers landslide, avalanches, flash flood, resulting in loss of life and property. You can see one view. I have taken from Wikipedia for explanation only. The earthquake is a detrimental natural phenomena causing disasters to the area, and the whole globe is directly or indirectly affected by earthquake events time to time in our history. Earthquakes are caused by sudden release of strain energy and that the rock had accumulated over prolonged time of many thousands of years. This accumulated energy is going to rupture the earth crust along some discontinuity or fault results in earthquake. The simple meaning of earthquake is a shaking of earth's surface is earthquake. It may be natural, it may be anthropogenic also. The rock strata or rock around the fault or discontinuity are weak and hence they are broken easily, and the broken side become site for the burst of energy and generating seismic waves. The powerful forces compress the rock along the fault for a prolonged period, and these forces will make them to break apart and move, that going to initiate the generation of earthquake. The sudden movements shake all the rocks around, leading to an earthquake. As soon as earthquake is generated in rock or rock strata, In the interior of Earth, the seismic wave is spread out in all directions and take only a few seconds to travel a long distance. Due to fast movement of seismic waves, we are unable to predict the situation timely to save the life and property of society. When these waves reach the surface, the ground shakes and an earthquake is experienced that is disastrous for life. A number of earthquake shocks also takes place before and after the main shock, as a foreshock and postshocks, and are termed as foreshocks and aftershocks respectively. The earthquake come sometimes in different phases. Some initially low magnitude earthquake occurs, then main earthquake occurs, then after main earthquake there is still some of the vibrations remain and causing the aftershock. In general, the propagation of velocity of seismic wave depends on the density and the elastic modulus of rock strata or rock. The velocity tends to increase with depth and ranges from approximately 2 to 8 km per second in the earth crust and up to 13 km per second in the deep mantle. In the absence of any resistance on the way, the P and S wave of all major earthquake travels quickly through the middle part of the earth to reach even the opposite sides of the earth. For instance, the tremor of an earthquake generated in North Pole and may be feasibly felt in South Pole due to fast movement of such seismic wave generated due to development of natural discontinuity in rock strata or rock. Regarding the seismic waves, characteristic and terminology related to earthquake for explanation, the movement of large section of rocks in the crust creates vibration called as seismic waves. Seismic waves are mechanical waves that travel outward from the focus in all directions through the earth. The waves generated due to such type of breaking of rocks or rock strata can be divided in two categories. First is body waves and next is induced wave of surface waves. The body waves is of two types, primary waves and secondary waves, or longitudinal waves or transverse wave. The surface wave is the induced effect of the primary and secondary wave, and the surface wave we have two types of wave, love waves and the relay waves. The love wave moves from side to side, however relay waves rolls like the ripples in the lake water, etc. The P wave is a compressional waves and is the fastest of the two body waves, and this wave is generated when the rock is pushed or pulled forward or backward. During the propagation of compressional wave, the particles of materials moves back and forth parallel to the direction in which the wave is moving. However, in case of S wave, which is also known as transverse wave or shear wave, and as the name indicates, shear wave cause rock in the shaken from side to side because it acts as a tangential. During the propagation of shear wave, particles of the material moves up and down perpendicular to the direction of propagation of waves. Next is love wave and relay wave, similar corresponding to this S wave and partially P wave combinations, as we have already discussed, going to damage maximum on the surface. The terminology we have hypocenter, epicenter and focus generally we utilize to describe an earthquake. The hypocenter is the point below the earth's surface where the rock first starts moving is the focus or hypocenter of an earthquake, defocus. The epicenter is a location, suppose this is the ground. If the focus is here, then the vertical projection on the surface we are going to recognize as epicenter, focus. The location on the surface of the earth vertically above the focus is recognized as epicenter. However, the depth of the focus from the epicenter is called as focus, just vice versa. The earthquake is described in view of magnitude and intensity of earthquake. The magnitude is the quantitative measure of the size of an earthquake, and its effects may vary with respect to distance, ground condition, construction standards and other associated surrounding factors. Each earthquake has a unique amount of energy, but the magnitude value given by the different seismological observations for an event may differ. The scale for magnitude of an earthquake is not linear. The energy released by an earthquake of a particular magnitude may be equal to the energy released by 30 earthquakes of previous magnitude. In such arrangement, we are going to see these scales. For example, the energy released by an earthquake of magnitude 6 is about 39 times that released by the earthquake of magnitude 5 and is about 900 times that released by an earthquake of magnitude 4. The energy released by an earthquake of magnitude 6.3 is equivalent to the energy released by explosion of the atom bomb in Hiroshima, Japan in 1945. The one of the widely utilized scale is a Richter magnitude scale proposed by Professor Charles Richards in 1935. He has developed one Richter magnitude scale by incorporating the relationship m is equal to log at base 10 a plus 3 log at base 10 8 delta t minus 2.92, where a is a amplitude in mm measured directly from the photographic papers of seismogram, and delta t is the difference in second between the times of p and s waves in wave curve. The Richter scale is presented in whole numbers, varies from 1 to 9 in Richter scale notations. It is such that the magnitude of the quake is 10 times greater than the previous whole numbers. For example, an earthquake of 6 has 10 times the force of that with a magnitude of 5 or so on. Besides this, we have another scale, Markelli intensity scale, regarding the impact based on the effect of earthquake on different buildings, society, roads, etc. In this scale, intensity is quantitative measure of an earthquake based on its impact on people, lands and building. It is denoted during the Roman capital letter. It is denoted using Roman capital letter, and the intensity varies with distance from the focus of earthquake, as the impact of any release of energy diminishes with respect to distance. Therefore, this scale is going to consider this concept. In a map of an earthquake affected area, the curved line showing the location of equal seismic intensity is called as isosismal lines, and the map is called as isosismal map. The seismic intensity of locality depends on the magnitude of an earthquake and locations from the epicenters, and this intensity proposed by this Mercalli scale used for many years was Rossi-Forelli scale devised in 1883 with 10 division designated from Roman 1 to 10, and the two common intensity scale currently we are using as modified Mercalli scale as Medvedev, Sponherer, Kornik, MSK scale, which is a microseismic scale and widely utilized in zonation of seismic zones of an area. And these two scales are similar in many ways, having 12 division ranging from 1 to 12 based on impact of seismic event. The earthquake waves are recorded by a device known as seismograph, and the record is called as seismogram. We have number of stations decorated with seismographs for measuring initiation of earthquake, and time to time the seismograph is going to produce data in form of the seismogram for proper analysis of earthquake shocks, nearby area and other. Based on these stations, we are also able to locate simply by drawing the circles, taking the distance as a diameter. Where these circles is crossing, that location is the location of epicenters. In this way we are going to see. The seismology reads the pattern of line in seismogram and measures the different parameters of earthquake. If we are going to divide earthquake based on origin, based on depth, based on nature, based on location, then we can utilize parameters like origin, depth of focus, then about location. Based on origin, we can say that the earthquake broadly can be divided as a natural earthquake and induced earthquake. The natural earthquake we are dealing as earthquake widely. It may be tectonic in origin and non-tectonic origin. If tectonic origin, then it may be due to movement or activity along the boundary of plates following the plate tectonics, or within the plate as intraplate earthquake. In India, some of the regions was declared as non-earthquake zone. However, we have received number of events like earthquake of Jabalpur and Latur and others that become example of intraplate earthquake, and we have declared these parts also as earthquake affected area. Then based on the depth, we can categorize shallow earthquake, moderate deep earthquake and deep focus earthquake depending on the depth of origin. Initially, we can divide the earthquake based on origin. It may be tectonic origin, natural, anthropogenic. In natural, we have tectonic origin and non-tectonic origin. Tectonic origin, we can divide the earthquake as shallow focused earthquake, moderate focus earthquake and deep focus earthquake. This division depends on the depth of focus in plate. Here for explaining this, and non-tectonic is associated with volcanic eruptions and other natural activity is going to generate seismic waves and cause natural earthquake. Anthropogenic is due to excavation of strata, due to injection of fluid, due to heavy level mining, deep mining, disposal of wastes in deep earth crust, and many activities which are going to disturb the earth crust in form of loading and unloading. If we are going to see here, in case of the converging plate boundary and diverging plate boundary, in converging plate boundary we have different type of earthquakes, particularly the deep focused earthquake caused due to breaking of this type of under thrusting plates and fall in mantle is responsible for development of the deep focused earthquake, where the earthquake located at the moderate type of depth recognizes, and the shallow level is due to movement of fault, rock blocks along faults and others. The such type of under thrusting situation is responsible or the variation in strike slip fault, thrust fault, normal faults, and other responsible for varieties of shallow focused earthquake. Intraplate, the earthquake generally occurs along this boundary we have discussed, but within this crust also there is a development of number of earthquake. We have number of examples like Jabalpur earthquake, the excellent and classical example discarding these boundary concepts related to earthquake. From our point of view, we have idea about the zonations based on different parameters. As we have classified, 90% of all earthquakes have depth less than 100 km, generally recognized as within 70 km, but some have more than 100 km. Faults or ruptures restricted to depth of 1 or 2 km produce minor earthquake or shallow level earthquake, and the crust of the earth is composed of brittle rocks at shallow depth. When we are going to enter deep, the brittle rock gradually started changing from semi-brittle to ductile, and in mantle we are having some fluid type of component, semi-fluid type. The breakdown of the crust occurs when the elastic energy build up in the crust exceeds the effective strength of the rock or rock strata in that form, and the earthquake associated with rupture on normal fault commonly reach the earth's surface, but when hidden inside the crust, as in the case of low angle reverse fault, only seismographs can detect them due to low magnitude. From engineering point of view, we have concept of seismic zonation map, and every country has developed its own seismic zonation map. For India, the seismic map zonation, which is based on extent of damage suffered by the region due to the effect of past earthquake, and based on the past experiences we have divided the zones in different levels up to zone 5. You can see the zone 1 area, zone 2 area, zone 3 area, and zone 4 area, and zone 5 area, where the one we are not going to consider. We are going to start from the zone 2 for this presentation. Zone 1 we are discarding due to feeble impact. The 5 seismic zones, zone 1 to zone 5. Based on the damages suffered in the region due to past earthquake in area with an intensity higher than Roji-Ferrell intensity scale 7, equivalent to the intensity 8. This gives a design criteria of severity of damage that each zone is liable to suffer in case of future earthquake as described in given table from the source book. And since then several modifications have been made by the Bureau of Indian Standard later on. This division from this map is showing from the zone 2 to zone 5. Nearly 60% of the area in India fall under the zone 3rd, 4th and 5th. The Himalayan region is within zone 4 and 5th, that is a landslide prone zone, earthquake prone zone and seismotectonically active in nature. However, peninsular India as per consideration was earlier considered to be a seismically stable landmass, but after the Kelari earthquake in 1993 and Jabal earthquake in 1997, there was change in concept, and these two earthquakes is going to modify the scales as revision. In the revised seismic zonation in 2000, zone 1 is a very low damage risk zone. Maximum intensity for 5th in mm or MSA scale has been merged with the zone 2nd by BIS Seismic Zoning Committee. BIS we are referring for the Bureau of Indian Standard. And there are now 4 zones numbered 2nd, 3rd, 4th and 5th in the earthquake zoning map of India. The intensity and probable earthquake damages that may be affected by these zones are as follows. Like zone 2nd, the maximum intensity in mm and MSK scale is Markeli scale and MSK scale is estimated to be 6th. This zone is termed low damage zone or risk zone. Zone 3rd is considered as moderate damage risk zone. 4th is area under this zone equivalent to seismic intensity 8 in mm and MSK scale, and this zone is a high damage risk zone. However, the 5th, but naturally it is a maximum damage risk zone. In view of this, we are going to plan for development work regarding development of road construction and others. Keeping in view the magnitude of the earthquake, impact of the earthquake, and considering one more parameter, response of the ground. Based on these parameters, people have started classifying any area in different micro seismic zones, and as per government mandate, it is important or necessary to carry out the micro seismic zonation map of area or develop map of area for recommendation concerned to any engineering, geological or civil engineering expansion is a concern. In 1962, Bureau of Indian Standard published the code IS 1893 for earthquake resistance structures useful for construction work, which includes the structures such as building, dams, retaining walls as per code. And in the latest revision of BIS in 2002, this code has been separated into 5 parts: big Direction regarding the different, you can read one by one by your own. Part 1 for retaining tanks, Part 2 for buildings, Part 3 for building and retaining walls, Part 4 for industrial structures, and Part 5 for dams and embankment. The BIS have given number of guidelines for construction of such engineering structures, useful for development and progress of society and nation and countries. In addition to this, time to time we have lot of modifications based on intensity and others. There is some role like Kelari earthquake, Jabalpur earthquake, Bhuj earthquake. After Bhuj earthquake, we have done lot of changes in our approach and consideration regarding earthquake. It is mandatory to design structure following the codes of earthquake resistance structure in an area of the seismic zones 3rd, 4th and 5th. Moderately affected, highly affected and very highly affected. Friends, this concept we have collected from the material maximum from the engineering geology book written by Gangopadhyay S, published in Oxford University publication, page 1 to 549, partially supported by engineering geology book written by Well FG in 2007. It's a thick book having page 1 to 551, and then partial supports from the textbook of engineering geology written by Kasabulu MC in 2016, ranging in page from 1 to 495. Friends, earthquake is a rapid vibration of ground caused by sudden fracture or movement of large segments of rock in earth crust, causing disasters to the society and nation. The earthquake is divided as tectonic and non-tectonic origin. You can divide natural and non-natural also. And the number of scales are used to assess the energy and impact, like Richter scale, like Mercalli scale, like MSK scale, Rogeforel scale, etc. In view of depth of focus, the earthquake is also classified as shallow, moderate and deep focused earthquake. Besides this, based on the location, it may be also called as the interplate and intraplate earthquake. And the seismic zonations are useful for various kinds of recommendation regarding the development program concerned to construction of engineering structures. Dear friends, in this lecture we have elaborated about earthquake, impact of earthquake, different type of scale, about some basic terminology, characteristic of waves generated to damage the engineering structures, and causes and division, etc. Thank you very much for your patience.